All right, welcome back, everybody, to day three of the Guided Application Program. It's good to see some familiar faces or names. Yesterday we talked about Python conditional statements and functions. We're gonna go ahead and continue and building off from that and shift towards ordered data structures. So we've learned a little bit about data types already. We learned about strings. We've talked about integers, booleans, floats, and you've probably heard me say the word list, a couple times throughout the last classes. And if you're fairly new to programming, coding in general, that might have sounded a little, confusing. What is a list? You keep using this word list, Roger, but you yet to use it. Well, we're going to talk about that today. We're going to elaborate a little bit more of how to use the list, how they work, the methods that you can utilize on a list, as well as another ordered structure um, called actually it's not actually an ordered structure. It's actually an unordered one. Um, it's called a tuple. Or I mean, it is ordered, but you see what I mean, right? So, uh, yeah, we're gonna talk about lists, and we're gonna be talking about tuples, right? We'll talk about lists first. We're gonna talk about how to create lists, the different operations that go into lists, and the methods that come with it. Just like we talked about with strings, there are a lot of built-in methods for this type of data structure. We're gonna talk about the biggest ones and more important ones. If you want to look up a little bit more about lists, you definitely can. There's not as many as there is with strings, but there is definitely a good amount. Afterwards, we move forward with tuples, which will do the exact same thing. And then because today's lecture is actually a little bit smaller than the last 2 days, we'll have even more time to do some exercises and kind of talk through the assignments. I do want to shift your attention towards my left side here on the directories. I have exercises, and we now also have today's lesson, 3 exercises within the curriculum. So if you don't have your code space, just be aware that the curriculum has updated. So you might want to update the code space. There was a small change to the curriculum a little bit. I added like 4 or 5 sections or 5 sentences to the end of tuples, but nothing major where you're missing out content. But all right. So ordered data structures, also known as sequences, are order grouping of elements, right? And the way that they're ordered is by index, right? Where usually in human language, we start our counting from one and up. Indexing starts at 0, right? So ensure you don't get that confused. Um, so in order sequence, it's ordered by the index, which starts at 0 and then moves essentially escalates or gets bigger as it moves to the right. And then we also have the backwards direction indexing, and we won't elaborate too much on this because we did talk about it while discussing strings, but we have here for a reason, and that's because strings are also some form of an ordered data structure, right? Uh, in the same way that we were able to access different characters in this string using indexing, we are going to do the exact same for lists, right? So lists are essentially containers or some form of variable that holds as the name implies, a list of data structures. Now, if you're familiar with other data languages, you or other programming languages, you will know that there are some languages that the type of data that is passed in within a list is limited. It has to be usually by default is like the same type of data, right? So it's either going to be a list of integers, a list of strings, and so on and so forth. List in Python is not as restrictive. You are able to mix in data. One thing to take into account about lists is they are mutable, right? They are mutable. That means, unlike strings, where when we try to update a string character, it gives an error. For lists, we are able to update the items in a list, right? If you recall, when creating the string, right? Small recap. We have S1 is going to be, Roger. And if we try to do S1 is equal to Aaron, these are two different strings. And we can print out the ID of S1 and also the print out the ID of S2. Oh, they're both S1. All right. And when we run this, we see here that the let's move this. There we go. My apologies. When we run this, we see that they change, right? When we first assigned Roger to S1, uh, it was something different. Then we reassigned Aaron, which I believe I misspelled. English is hard. Um, and then ID of S1 is different, right? These are two different strings. They're not the same thing, right? They are immutable. For lists, that is the complete opposite. Lists are mutable, meaning we can update a list. And the way that we create lists is by using, or essentially, the way that we instantiate or declare them, or how you can differentiate from everything else, is the square brackets. So we can have a variable here called list of animals, and we will start a list here by using the open and close square brackets. And every item in this list will be separated with a comma, right? So the first item that we wanted to add, let's say we could say cat. This will be the very first item in this list, which will be at index 0, right? Going back to the way that they're ordered, we start from 0 onwards. So even though it's only one item, it is not at the first position. It is at index 0, right? Now to add another item into a list, I'll pause here. I see a question in the chat. Is it possible to print or call the contents of memory space solely by its address? I'm pretty sure there is, but I don't know off the top of my head. Let's try it. We would have to switch over. I believe we have to. So the same way that we are casting the ID around our variable, I would assume there is a wrapper that we would have here that would convert it into whatever its name it is, right? I don't know off the top of my head, Stephen, but the same way that we were able to convert a string into an integer, then an integer back to a string, we could probably do the exact same thing. Do not quote me on it, but I'll give you an answer after the break, but I'm sure there should be a way of doing that. I don't know if Python gives you that much flexibility on doing it. There are some other languages that allow you to mess around a little bit more with memory space. I don't know if Python has that flexibility. But moving on. So here's our list of animals. We have cat. And to add another one, we can solely just, strictly just go ahead and add it in here if we want to manually. Or we can use some other methods to do this. But we'll start off simple. So we have cat. We'll want to add dog. And then to add a third item, we do another comma and we can say bird, right? And this is our list of animals. They're all of type strings. I could also do list of randoms, right? And this could be a string of apple. This could be an integer of 12. We can have a float of 4.5. We can have a Boolean, and that's okay, right? If you recall what I mentioned earlier, unlike other languages, we are able to mix both of these and not get an issue or mix data types. And we print both of these out, they both succeed, right? We get list of animals, it prints out the entire list, right? When we can print out the entire list and it'll print it as such, right? In brackets to let us know it's a list. And then we have the list of randoms. Notice that these are all different random, different data types. They're not all the same, and we still do not get an error, and that's okay. All right, so lists, they're immutable. We're able to change them, and we'll talk about them in a little bit. We can remove, we can add stuff, we can rewrite items within this list. They are declared using the square brackets, and they can be a mix of data types, unlike other languages. Now, let's continue on. So you saw me declare a list here in a very specific manner, right? I added the brackets right off the bat. Uh, Python knows that this is a list because of these square brackets. Now, there's actually a other way of declaring a list, and funny enough, this is actually very new to me. I was not taught this. I don't know anybody that uses this method to declare a list in Python. So I thought it was kind of interesting when I was reading through the curriculum, and I was like, really? I did not know it. I have never seen anybody declare a list just calling the list in parentheses, but you are able to initialize or essentially create an empty list by using the built-in method from Python that's called list and open and close parentheses. Now, something to take into note. This is a built-in method. So if later on your code, you did something like this, where you tried to declare a variable and called it list, and you added, whatever in here, apple, like a string of apple, this will overwrite this built-in method, right? And that's one of the important things about not using these reserved words or keywords that come with Python. You want to use something that is not only is it unique, not related to Python restrictive methods, but it's something that makes sense to the program or what you're trying to accomplish, right? So something to keep in mind. It does override that if you try to use stuff like list. And just like we don't name a list just list, we wouldn't call a string string, or integer, or essentially int or str, right? These are stuff that we don't want to do. And I get a question here. So list with square brackets is more flexible. To be fair with you, I've never used this, but let's actually give it a try. Right here, they're using a method called myList, and they create a variable called myList. I'm sorry, I misspoke. And they pass in this list method here, and we run this. If we're printing out the myList here, let me do this very deliberate so you guys can see what's happening, right? So we print out the myList, and it returns square brackets. This successfully created a list, but what if we did something like apple inside of here? Right, by passing the string apple, it took the entire string, broke it apart, and added to our list. What if we did something like apple, comma? Does not like that. What if we did apple? This will work, but this will kind of defeat the purpose. So you see that now. Hopefully that answered your question, Johnny. This will create an empty list by default. If you pass in a string, it'll break the string apart. But what if we did something like 5 times 3? I did not. Never mind. I thought it would show it 3 times, but it's okay. Yeah, it looks like list isn't maybe the most efficient way of doing this. If you wanted to create a list with some very deliberate data in it that you're aware that that you want to have in there, maybe it's better to just add the square brackets. And to be fair, and probably the reason why I've never seen it written out that way is it's 2 keystrokes over the typing of list in open and close parentheses. You can do the exact same thing by just declaring the name of what your list is going to be called and just opening and closing these square brackets. So just something so you're aware of. You do have this list method. Both of these will create an empty list, but it's probably just more ideal to just use the square bracket and then pass in deliberately what you want to give it. Do I have any other questions before I move forward? All right, moving on. Uh, so this just continue to tell you that if you overwrite the list, you would essentially have to restart your Python kernel so it understands what's happening. Um, Here we have some examples of creating a list with data or elements already inside. And we saw that through my initial example. We have here the num list, and it's essentially just a list of integers from 0 to 9. And then we run the num list and it prints out exactly that. Uh, we can also use the type method around this list. And what do you think is going to return to us? Correct, a list, right? So it's smart enough to be able to identify what type of data structure this is. You know, we're able to identify if something was a string, whether it's an integer or float. We can also tell if it's a list. We can use what we've learned before and say something like if num list is equal to type list, print this is a list. Uh, I guess not liking this. What if we do list? Or if we do type num list, this doesn't like me. I don't know why. There we go. Okay. I thought I could check the type, but whatever. It did not like that. So here we do if type num list. What does this return to me? It returns to me the list type. So we're saying if this is a list, which is true, then print this is a list, right? Um, Else, and actually, it'll probably make more sense if we specify this a little bit different, like type. What if we did something like, mm, there we go. I think this is so much better. If type num list is equal to the type of whatever this is, which is a list, print this is a list. Else, uh, print this trash code don't work. There we go. Well, here we're checking if the num list is equal to a list. Then I want to compare it to the type of whatever this is. And if these are the same, then I want to print this in list. What I had earlier, what it'll actually do is check whether it's empty or not, if I'm correct. And that's not something that we were trying to achieve. This will always pass, but it'll check if it's an empty list or if it's not an empty list, and which is what I didn't want to do. So I reformatted my code, and here we're actually just doing a comparison, adding to what we learned yesterday. But that's one way that we can use the type, right? Or knowing what kind of data structure we're working with to our advantage, right? For example, like if you were what's a good example? Maybe like taking in input from your user where like you ask for a first name, but the little goober gives you integers, right? That's probably not something you want. Like your name shouldn't have an integer. So and you could add that in your code, like, hey, if type is digit or whatever, or if type is int, then return, this is not a valid username or something very similar to that. So we could do that, but without derailing any further, yeah, so we were able to check that it's a list, and it does return to us a list type, which is awesome. Moving on, we can also pass in a list within this list, right? So we saw adding strings, adding integers, adding floats, booleans. You can also add another string. I'm sorry, not another string, another list. And then even other items in here, which we'll talk about later. But it's not just strictly to your basic data types or data structures. It can also nest itself. here we have a list with lists where the first three items within this list are strings, but the item at index 3 is a list itself, right? And then we can probably take this even further, lists with lists with lists. And, and we can nest it as far as we need, right? Here we have a list of lists, and then the second list has a list of other empty lists. Uh, and it can go further and further, however you want it. Probably not ideal. This isn't, pretty cool at all. But you'll see nested data, something very similar to this when you start working with JSON and whatnot. But that's a little out of scope. But yeah, no, we can nest stuff within here. So it will take another list as one of the elements within itself, right? So something to keep be aware of. Do I have any questions before I move forward? Is that considered a matrix? Technically, yeah. I'm sure you've seen that in your lead code challenges. But just be aware of that you can list these different data types, right? Data structures. All right. We next are we going to talk about the list operations and our methods. So we talked about declaring a list. We talked about the different data that goes in there, but let's actually talk about how we can manipulate this list, add things to it, delete things from there, and so on and so forth. Right. So here we have a list of travel locations. We have New Zealand, Antarctica, Italy, Chile, Fiji, Ireland, and Morocco. And then we're just printing out the list. Right. Nothing crazy. Very straightforward. We saw that before already. It's just a list of strings. Now, let's talk about accessing specific items within here. And this might seem a little familiar already because we kind of already did this with strings. But the way that we're going to access it is by using indexes, right? The index of the item that we're looking for. And the way that that's done is you call the name of your list, and immediately following the name, you open and close some square brackets. What goes within these square brackets is the index of what you are looking for. All right. So here we have the syntax, which is a list variable, and then open and close bracket with some kind of word or letter in here of n. And n could be anything, right? It's an imaginary number. And this will essentially access the items that assigned at this specific index. If this index was index 1, that would return to us Antarctica, right? Now, to change or set things within that index, very similar to how you assign stuff into a variable, that's how you would assign things into that specific index. First and foremost, you have to call the index. So we see that here. We have the list name, open and close square brackets with the index we're trying to update. And then we use the equal sign to show that we are trying to assign something into this index, and we pass it a new value, right? So we set the value of index n to the value of whatever x is, right? So we have how to access items in a list and how to set items in a list, right? Very, very specific. Let's see that work out. What did we do? Travel bucket list. We could do that index 1 that we mentioned. They should return Antarctica, which is correct. And let's go ahead and now update index 1. And we're going to say this is a country, right? Let's go with Greece. And afterwards, let's print out travel bucket list. All right, so we essentially run the travel bucket list, and it prints out its original, right? We then update Greece and then reprint it out and see how Antarctica changed into Greece. So we're able to access different things and then update them accordingly by the index, right? The same way that we would reassign, a variable. All right, moving on. So we talked about accessing. We talked about setting something to a new value, but we can also do what we did with strings, which is slice through the string, right? We use the bracket notation once again, and we use the colon to specify where we want to start and then where we want to stop within the slice, right? Here we have travel bucket list of index 4. This is going to return a single item, right? Which, as you see here, was Fiji, right? We have New Zealand, Antarctica, Italy, Chile, and Fiji. Even though it's the fifth item, it is at index 4, right? New Zealand is 0, Antarctica is 1, Italy is 2, Chile is 3, and Fiji was 4, right? So at index 4, we return Fiji. Now, who can guess what this is going to return to me? And this is going back to Monday's class of slicing through the string. Correct, Nicholas. It's going to return to me a reverse string. We don't specify the start and we don't specify the stop, but we are saying to go backwards, right? -1. And that returns to me a reverse list, where if you saw earlier, New Zealand was first, and then Antarctica, or it's actually Greece now. Let's go ahead and remove this. This is not updating it. There we go. And we run this. There we go. It went New Zealand, Antarctica. It reversed the entirety of the list. So the same thing that we did that with the string, we were able to do that with the list. What's happening in this line of code? And what is this going to return? I know this is, for some of you, this might sound super simple, but I promise you there's some people that are still learning this. What is this? You guys are very quiet. Assigning index 4 to taxes, absolutely, right? So it's grabbing whatever's at index 4, and that's important, right, to say index 4, because when you first start off, you get confused with the indexing. We are reassigning it taxes, and then that should have been Fiji, if I remember correctly. And we see here that it now returns a more updated list. We're able to change directly the item at index 4. All right. Do I have any questions about accessing, setting, or slicing a list? All right. Let's go ahead and move forward. List operations. How do you access a list in a list? That's a great question, Brandon. Let's cover that before we move forward. So, I'll add a new code here. This is going to be list of lists. And we have a couple lists here. The first list is going to be strings. The second list will be numbers. And the third list will be floats. So 1.2, 2.3, and 3.4. If I want to grab the second list here, which is at position index 1, I would do a list of lists, bracket, and then passing 1, right? That'll return to me, excuse me. List of lists is not defined. List of, my apologies, list of lists. There we go. List of lists. right? That returned to me that item that was in that list at index 1. Now, I want to grab the number 3 within this list, and this list I know is at index 1. So the way that would work, and I'll do it on a separate line, I would say list of lists. Well, what list? We have to start at the global scope of inside this list, right? What is the top level of this list? A top level is here. So I have to take care of the top level first. Well, which one of these lists do I have to go into? Well, it's going to be this one. So index 1. So I start in index 1. And now I'm within the inside of this list. I want the item or the number 3, which is at index 2. So literally right after that index 1, I would open and close brackets and say index 2. And when I run this, we see here that it returns to me the 3. Let's print both of these out. There you go. Right. Roger, how do you grab a list that's within a list within a list? Same concept, Jimmy. Right. If we have here a list of other numbers, this is going from 9, 8, and 7. We came here, right? We're still in here at inside of this index. In index 1 will bring me into the top level of this first list. And then I got to go into index 1 again. But this time it's saying, hey, index 1 of index 1, right? Does that make sense? But the second index brings me into whatever say the index 1. And now I want to grab the item at index 0. Let's say it's 9. So I would say open and close brackets, index 0. And you see here that I grabbed 9. So essentially all I'm doing is kind of digging myself a little bit deeper into this whole, going down deeper in the levels of this nest, using the brackets to go further and further into the data. Does that answer your question, Brandon? That was a good question, actually. All right. Let's go ahead and do this. All right. So, list operations have some awesome methods that you can use. One of them, which you kind of already saw a little bit earlier in the week, I believe yesterday, is the LEN, which stands for length, right? We're able to check how long a list is. If you are familiar with JavaScript, I believe the command for that would be like travel bucket list dot length, and it would spell it out. In Python, it's different. We wrap the bad boy with the len wrapper, right? And put the list that we're trying to check within the parentheses. And when we run this, we see here that travel bucket list returns 7. This is the list right here. And if we count the amount of members in here, we see 1, 2, 3, 4, 5, 6, 7. Important to note that to count how many elements are within a list, it does not start at 0, right? So don't get those confused. The positions in the list uses index notation, so that starts at 0. But to actually count how many items are actually within this list, we do not use 0, right? So it returns 7 instead of 6, right? So keep that in the back of your mind. So we were able to check how long your list is by using the len method, right? So that's one of the cool methods that we can use. Len works on strings as well. Whatever you want, it works. I don't think it works on integers actually, but it works on lists for sure. Now, we can also use membership checks, if you guys recall yesterday, right? We can say something like Fiji in travel bucket list, right? So this is a list of the different countries, and what does this return, guys? What is a membership check return?
Boolean, so true or false.
Correct. It returns a Boolean, right? So it's going to tell us true or false if Fiji or if taxes actually exist within this list. And we see here both these come, or not actually, both Fiji comes out to false, and then Texas comes true. And I believe that's because we changed Fiji here, right? We updated Fiji and made it Texas. So yeah, it returns a Boolean. So we're able to use membership checks to check if something is within a list, right? We can also use loops to iterate and perform operations on each element. But that is on next week on day 5. So we're not talking about that, but we are able to do that. And actually, just to give you a sneak peek, I'm sure you've seen some of it like this. For countries in travel bucket list, we can print travel, or we can print countries, my bad. Countries. We're able to loop through the list and print out every individual item within this list. So we can do stuff like that, and we'll talk more about that next week when we get into day 5. But that is an option. All right. Next, some additional methods, right? We talked about how to access. We talked about how to set a specific index to a new value. But what if we wanted to remove something, right? Or if we wanted to add something to the end of the list? Um, we have some options here. We see here we have the first one, which is going to be your append, which does, and you'll see that almost everything in Python, it does really what the name states. That's why Python is so awesome, because very readable. But essentially, what we're doing is appending something into the end of the list, right? And that's important to note. We are appending at the end. So the way that works is you call the list you want to append something to, right? And we see here the default example. They just call a list. They use the method dot append, right? So after you call the variable of your list, you use the dot append method right afterwards, and you pass in the item that you want to add into the list. And we see that here. We have that travel bucket list, and let's print it out before we move forward. But we're able to print out the entire bucket list, and it's not printing it out the first time. It's printing out the second time. There you go. We print out the first time, and I'm sorry. What? Why is Germany in here? Oh, clear all outputs. Why are you doing? Say restart. Restart. There you go. This works like code. So if we add stuff, it's gonna keep adding stuff to it. All right, there we go. Let's run this. Append Germany, travel bucket list is not defined. I have to run it somewhere. Give me a second, y'all. Let's go ahead and let's run this actually. So the way this works, guys, is actually saving these variables. When I run the code, I had to come back up here and rerun it. So it instantiates or creates this variable. So it knows to access it somewhere else. So I have to run these so this actually happens. And now down here, I can actually use this. There we go. Right, so I run it. And we see here that the first time we print out the travel bucket list, Germany is not in here. We then run the next line, which is travel bucket list.append. And we're appending the string Germany at the end of this list, right? And the second time we run it, it does exactly so. And you're probably wondering, Roger, why is it in a different format than it is up here? I believe it's because of spacing. I think at a certain space it just moves downward. So don't fret. There's It's the same list. It's just formatted a little bit different to display it to you. But Germany successfully was added to the end of the list, right? Using that append method. So append allows us to add things to the end, right? Very important, the end. All right. The next one is going to be the extend method, right? And the extend method extends the list by appending elements from the iterable. And you might think to yourself, Roger, doesn't append do the exact same thing? Um, yes, but not as an iterable, right? What does it mean as an iterable? What's an iterable? Now look at guesses. Okay. An iterable is something that you can iterate through, right? Uh, and iterating through is just essentially just going through every individual item within something, right? And that's a list, right? And a list has multiple different elements. It could be either zero or more, right? But you can go through every single element, and you have the exact same thing with strings, right? It is a sequence of characters, right? We're able to iterate through every single character, go by one, and that's what the extend method does. It essentially iterates through the items that are passed in within here, and then appends them to the end of the list. And we can see that at work here. This travel bucket list list originally, we use the dot extend method. And then notice the difference between the extend and Germany. Germany took an individual string, right? One element, one string element. And then the dot extend took it a list of strings. And when we run this, it has something very similar to the original. And you would think, well, both of these accomplish pretty much the exact same thing, Roger. This one added to the end of the list as well. And so does this one. But what happens if you try to use the extend method with a single string? Well, let's try that out. We can say travel bucket list dot extend. And I'm gonna go ahead and say France. Right? Instead of passing a list, I just passed it in a single string. When I run this, France travel bucket list. Give me a second. There we go. We see here that at the end, it added France, but not how we thought it would. It broke it up into individual characters and added them as such, right? So the extend doesn't work exactly like the append. It iterates through whatever you give it and adds it one by one. Well, because this was already an iterable, right? A list, it was able to add every word inside this list individually. If you recall, a list is very similar to also a string because a string is also a sequence of stuff. It's a sequence of characters. So it takes that string within the extend method and almost works it as if it's also a list of characters, right? Yes, in a sense, Johnny, it works like a for loop, right? It goes through every item within your iterable and appends them one by one. Uh, does that make sense to y'all? Do I have any questions before I move forward? All right, so let's go ahead and delete this one so it doesn't mess with my stuff. Let me run this travel list again. All right, so we talked about a pen, we talked about extending. Uh, Next one is gonna be your insert. Right, so insert. Notice that this insert method takes two different arguments, right? We still call the name the list. We call the insert method, but the first argument we pass in is an integer. Can someone take a lucky guess on what this integer is? Correct. It's the index, right? Um, it is the index. So by adding insert, you can specify where you want to insert a new value. And then the second argument you pass in is the actual value you want to insert. And when we ran this, we see here that at index 0, Canada was added. Well, let's try this again. Let's say that at travel bucket list, I want to insert at index 4. Let's go with Russia and print that again. My bad. Print travel bucket list. And we run this and we get Canada still in here. Oh, it ran my code again. I apologize. We get New Zealand, and eventually it does have Russia. It essentially scooches everything over to the side, to the left and right, or actually the right, and then deliberately adds it in here, right? One thing to note, this isn't the most efficient thing. Imagine if you had a list of over like 1 million different data types and you try to insert something into index 5. What do you think is going to happen? Then your computer will have to go through every single item and move it over one index, right? You could, maybe, I don't know. It might take forever, right? It will probably take forever. It'll probably take like a good like 30 seconds. Probably not. No, I'm exaggerating. It take a while. It won't be as fast as it is here. It'll definitely take a couple seconds instead of just being very specific where it just did it right off the bat. But that's probably not efficient, right? So just be aware of stuff like that uh, of inserting into large pieces of data. But just know that you are able to deliberately do something like this. And I want to, can I reset this? I won't. Let me reset it. How unfortunate. Oh well. All right. So we were able to insert Russia in here. We have Canada. Uh, we talked about the append. We talked about extend. Uh, we talked about the differences between them. There's actually already a code block for this. You can run these, but these will do two different things. Right. So as we saw here, the append takes in a single item, and the extend will always treat it as a sequence. Right. We saw it treated a list as a sequence, but it took in the string as a sequence as well. Right. Uh, Now, so next we're gonna talk about removing items from your list. Let me go ahead and add a code block here, travel bucket list, and let me print it out. We'll use this part of the code to kind of format our list. We see here that I made some changes to my list throughout this lesson. I added Canada twice, which is not ideal. We have Russia and we have Germany, so our list has changed a lot. Well, the next thing we're going to cover is removing things from our list. And there's two ways of, actually probably three. There's three ways of deleting something or removing it from your list. And I see here a question we have. I am confused what an argument versus a sequence is in the above explanation. Uh, an argument is something completely different. Where could you point me towards exactly where you're getting confused in here? Either through the chat as we see here. Okay. Uh, so an argument is not the same as a sequence, right? We use argument and parameters as interchangeable words, but a sequence is something else, right? What this is saying is whenever we use the append method, right? Append, extend, insert, what are these? Could you explain that to me, Esperanza? What are these? And we've used the word before. I explained what these are. What are these essentially? Someone help out Esperanza, or if you want, you can phone a friend. What essentially are stuff like append, what's extend, insert, functions. Thank you, Rashawn. Perfect. They're functions. And if you guys recall from yesterday's lecture, functions, we essentially define parameters, and these parameters are uh, optional or sometimes, most of the time, it's data that these functions need to take to work, right? It's the ingredients of what functions take, right? It's like a recipe is what I used yesterday. Append and extend. It's essentially a recipe to accomplish a task or create a dish, right? And there's ingredients to recipes, right? You can't make a cake without eggs or milk, right? Same thing with this function. This function requires a couple things. Insert requires two ingredients. It requires the index that you want to add something into, and it requires what you want to add in there, right? That's what this specific quote unquote recipe takes to complete its dish, right? This is what this method does. That's what an argument is, right? An argument is it's that parameter. By saying adding the argument to the list as a single item, right? We're saying that we're passing in this list, or I'm sorry, this list as an argument into this function, right? Argument is the pretty much the exact same thing as the parameters, or in other words, ingredients of a recipe slash um the or of the function itself, right? We use arguments and parameters interchangeably. Parameters is what we call it when we are defining the function, right? That's what we're calling when we're defining a function. When we are actually calling the function and utilizing it, we call it an argument. This is what we're passing in as an argument, right? So they're essentially the exact same thing. When they're used is where they're different. Does that make sense to you, Esperanza? That's what an argument is. Sequence is something completely unrelated to that. A sequence is kind of like in the name itself. It's something that has some form of an order, right? Um, Goes from like start to end, from 0 to 1 to 2 to 3. That either increases, right? But what is the sequence of the alphabet? A, B, C, D. What is the sequence of the indexes in a list? 0, 1, 2, 3. That is a sequence. What type of data structures are sequences? A list and a string for one. Those are sequences, right? They have some form of order that they go in. And the order that they are a sequence of is from 0 and onwards. So on the other hand, the extend will always treat the argument as a sequence of things. So what does that mean? Well, when we call the extend method, once again, what is extend? Extend, question mark, it is a function, right? So that's what it's saying. Extend will always treat the argument, because this is a function, we use open and close parentheses. And what do we know about functions that we just discussed? They take in arguments, right? Our ingredients of our little recipe, our function. So extend takes in arguments. Well, what could be an argument? Essentially anything. You can pass in a string, you can pass in a list, you can pass in float, you can pass in a boolean, whatever you decide to do, that is your arguments, right? But what it's saying here, right? That it will always treat the argument as a sequence of things and try to add each individual item to the list. Is that unlike the append, right? That it took it all as a whole. It did not add these items individually. It treated it as a whole. Extend doesn't do that. It'll break it apart and treat it as a sequence. That's what it's saying. Does that answer your question, Esperanza? Awesome. Yeah. And that's the importance of why I use the terminology. It's because we can get very confused with stuff like what is an argument, what is a variable, what is a function, what does it mean for to use parameters. I keep hearing you say these, right? So one thing I recommend to you guys, especially if you're brand new to this, is you can create flashcards. So you can either do it manually, and all these terminologies that we're using, like the names of different types of data structures, like a string, a list, an integer, a float. I would write these down, right, and then add the definition at the back of the flashcard and ensure that you understand what this terminology means. Um, and how they work, right? And this is very important for you guys as brand new coders. And the way that you can do this, if you don't like flashcards, you can use what is known as Anki. And I don't know if you guys have ever seen something like this. I usually talk about this in my Foundations of Programming course, but Anki is a digital flashcard application, and it's free to download, and it takes like 2 seconds to download. Uh, and ignore this update. And I have a couple ones here where I made some examples here, but you open up this application and you can have it on your desktop and you can create a new deck. And then for you guys, you can have something like Python um, terminology, terminology, right? And then that'll create yourself, for you, a new deck. You can open this deck up, and congratulations, you have finished this deck for now, right? What you're gonna do is you're gonna add something new, right? And it opened it up on my other uh desktop, but here it'll open up something very similar to this, and what you do is uh ignore this. This is not important, and this is not important. You can add a front and a back. And what's gonna happen will be like, what is a list? Right? You would add your question, and in the back you would have your answer, a sequence of data types, right? And then you add it. And you can keep going through this. You keep adding different cards, and when you're done, uh it kind of brings you somewhere here. You can go back to your decks. Notice that Python terminology, it's new, and there's one item in here. I can open it up, and then I can put study now, right? And then it'll essentially randomize your flashcards, right? Your digital flashcards, and then you would ask this to yourself, like, what is the list? Kind of verbally say it out loud, and then when you're ready, you can say show answer, and it shows you. You're like, oh, thank you, I got it wrong. And then you can give it a rating: hard, good, and easy. If it's hard, then what would happen is this will come out, within 6 minutes. If it was like, impossible, you're not even close, you can put it again, and this will give it a rating of again, saying that, hey, I need to see this again, like pretty soon, and this will give it a rating of 1 minute. And notice here, it puts a timer on this, right? It puts a timer on it, and then um you will continue on. But this is something I recommend, especially if you guys just started coding and you're struggling with understanding some of this terminology, or you're losing or you're getting lost whenever I'm saying some of these things. Maybe create these as we go through our lessons of guided application. This will help you learn a lot faster. And honestly, if you do these, every day for 10 minutes, that's all it really takes, just 10 minutes. How often do you guys get online on your computer and you're just watching YouTube videos of like cats, right? So, that time that you're wasting just watching these 20 cat videos, just open up your Anki and then go through your flashcards. and take that time to ensure that you understand what you're learning, and solidifying that foundation. And the reason why this is so important is because when it comes to your technical assessment with Guillermo, you're gonna be a little stressed. It happens to everybody, right? Even though he's not like an intimidating guy, he's not gonna bully you or anything. He's a pretty chill guy. Because it's gonna be like almost like an interview environment. You're gonna feel a little nervous and you're gonna feel stressed. And what happens whenever you're in a stressful environment? And for those of you who are in the military, you probably already know this, but whenever you're under stress or you're anxious, you always resort to your lowest level of training. And that's just by nature. You can practice all these advanced subjects and topics. You might be going through all these leak code videos and you think you understand it, but unless you solidify this foundation, uh, you won't really understand it. And that's what's really important. And the purpose for classes like this, foundations of programming or the guided application, it's to really solidify that foundation before you start moving to more advanced topics. Because when you're stressed out, especially in this technical interview, you will always resort to your lowest level of training, no matter what. You're like you won't even think about all this cool for loop that you saw some dude do on YouTube. Like, oh, I never even knew you could do that with code. I'm gonna use that on my next interview. You're not. I promise you. You're gonna get too nervous, you'll forget it. So practicing the basics like this on a flashcard will really help. But that's enough for my rant. I do apologize if I talked your ear off. Time is 7:02. We're gonna go ahead and take a 10-minute break and return at 7:12. I'll see you guys then. All right, welcome back, everybody. We're gonna go ahead and continue with today's class. I went on a little rant before we went on break, but hopefully that kind of gave you a new tool to work on, so you can better yourself. Repetition always helps. Just over and over again, seeing the same thing will help you kind of remember or click. But back to what we were talking about. We were talking about removing items from a list. And we have two methods here, and I'll show you a third method here. But just like before, we're going to call the list that we are trying to update, and we're going to use two different methods, and both of these work their own way. We have remove, which is going to remove the first appearance of X in the list, right? X being whatever number, not specifically X, but whatever's actually assigned to X, right? So if you have this string right here, I'm sorry, this list of strings, and you wanted to delete something from here. For example, let's say Canada. We have two Canadas in here, and I obviously don't want two Canadas. The remove method is probably a good one to use here to remove the very first Canada that I find. And the way that I would do that would be by saying the name of the list, which is travel bucket list. And then I use the dot remove method on this list. And then I want to remove Canada, right? And then afterwards, I can go ahead and print out my travel bucket list and see what that's giving me. And when I rerun this, we see here that initially the first time it's printed out, we have both Canadas. And the second time it runs, it no longer has one of the Canadas because the dot remove method was successful, right? So the dot remove is a great way of removing something. And then there's there's another way that we can use, and that's going to be the pop method. And the pop method is going to remove the item at either index I or the last item on the list, right? So once again, it's going to remove the items at index I, or it's going to remove the last item in the list. And we'll see that work here, right? And it also returns the item. So what does that mean? Well, let's create a variable here. We're going to say last item, and we're going to assign this to whatever returns from the dot pop method. So I'll call the travel bucket list, say dot pop, and I want to pop whatever. Oh, I want to get rid of Russia, so let's check out the Russia one. We're going to check the index. So index 0, 1, 2, and 3. So I want to remove index 3 because I'm trying to bring my list to be back to what it originally was. So I'm going to remove the item at index 3. And then afterwards, I want to print out whatever last item is. and then also print out whatever my travel bucket list is. So we can see how that looks like before. And we can go ahead and comment out the other code prior to this. And when we run this, we see here that this slide runs. It prints out my travel bucket list. And it's my original list right here with the changes of Russia, Canada, and Germany. I then pop the item at index 3. And as you saw here, it returns that item. So after it removes it from the list, it's also going to return it if I decide to assign it into another variable. And when I print out last item, it actually prints out that item, Russia. But notice that also on top of that, I'm printing the travel bucket list once again, and we see that Russia is nowhere to be found. So not only will it remove it from the list, but it will also save it into a different variable. So it does two things at a time, right? Do I have any questions about using the pop with a specific index or how we assign it to a variable because this returns something after it removes it? Let me open the chat. Okay. I don't see anything, so we're gonna go ahead and move forward. Let me go ahead and comment this out. I see if you pop without placing it somewhere, does it go away? Yes, Nicholas, it does, right? Very similar to how when we reassign a variable to a different string, I mentioned that because that original string no longer has a variable name, it doesn't have an address. So what happens to it is not that it doesn't exist, it gets added to collections, right? So uh, periodically, what Python does is anything that isn't useful, and by useful, I mean if there's any kind of values that you have in your code that you no longer are referencing, then what happens, it gets added to what's known as a recycle bin, right? For in human terms or layman terms, right? But essentially, it's collections, right? It's for trash collection, and periodically, Python will empty out that trash bin, right? If it no longer exists in a list, it gets added to this collection box in a sense, and then eventually it gets deleted, right? Think of it as um, adding a picture to your trash bin, and then every hour on the hour, you're like, I'm just gonna go ahead and empty my recycle bin. That's essentially what's happening, right? So if we remove that and don't assign it somewhere, if that just kind of fades into collections. Uh, Now let's talk about using pop with no index. Let me go ahead. I no longer need this, but I'm gonna go ahead and use pop. Can you recall an item that was removed with pop? If you removed it and you didn't save it somewhere, as far as I'm tracking, I'm like 99.99% sure you lost it. You wouldn't be able to get it again. Um, right? But yeah, so let's go ahead and use travel bucket list, and then we're use the dot pop method again. And then we're gonna print out the travel bucket list. Notice that we don't save it to any kind of variable. We don't add an index. Right now, this is what it technically should look like. And then we invoke the pop method and we're gonna print it out again. And we see here that it removed Germany uh, at the end of it. We didn't specify where to pop. It's just by default going to pop the last item within a list. So that's one way of doing that. Now, I did mention there was another one, uh, which we'll cover in a bit. But yeah, so we saw the pop method, we saw the remove. Here's the examples that were already on the curriculum. We had the travel bucket list, and it was removing something specific here. So we have Japan. We don't have Japan. But let's run this. All right, removes only the first entry, so there will be another one. Blah, 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 blah. Where does it encounter the J? Where is this one coming from? Did I have it originally here? I'm sorry, I kind of went on my own, not using the curriculum.
So I was surprised. I was trying to.
Yeah, I should I should have continued with the curriculum. That's okay. So, let's go ahead and do something like this. Is there a J in here that's capital? Let's clean up the mistake we made. Okay, so my apologies. So it pretty much was doing the exact same thing I was doing. But let's go ahead and I wish I could bring this back. Oh no. Let's print out travel bucket. Let's see what it looks like. And this, I mean, this is good. It's okay that I make mistakes like this, so you can see me kind of debug it, and hopefully that kind of shows you how to do stuff. So, all right, we print out Japan here. Let's just go ahead and add Japan for some giggles. I see. So can someone repost the attendance link? Uh, Let me post it on the chat. So we're gonna go ahead and add Japan in here. So we'll say travel bucket list dot append Japan, and then we can print out the travel bucket list, and we see that Japan was added at the very end of it. And now the rest should work. If we run this, I guess it's gonna want something like this, where we say, what index is this? Let's remove this, put it here. String object has no attribute remove. Okay. Oh, my bad. We're correcting the extent. Oh, that's okay. That's coming back from when we used the extent and it took it as a sequence and broke it apart in different strings, right? So instead of having the the word Japan, it pretty much had it as broken up into individual sequences. And that's okay. We can go ahead and continue moving forward. We don't have that issue here. We remove the A. We talked about pop. Uh, Notice that they're using the -1 here. So it removes the last entry. So we can add whatever specific index we wanted. We saw that. It also uses a -1. And we also saw how we could remove specific ones using the remove function. Uh, and how to remove the last item by not specifying anything. But does anybody have any questions on the remove pop? Everything else has pretty much been covered. I just kind of did it in my own example without using the curriculum. Right, and what Nicholas is saying is absolutely correct. Right, here we appended Japan as one, and to correct any confusion, what happened was, let's go ahead and remove Japan. And then let's go ahead and use travel bucket list dot extend, and we're going to extend it with Japan. And when we run this, we see, we don't see it right now because I'm not printing it out. But if I print Japan for the travel bucket list, Japan is now JAPAN, right? So what this is doing is removing the individual letters, right? So we run this again, we now have only A. So then they ran remove again with A, and now it removes it and it's fixing that error that we had, right? So the next one I want to talk about, which is not in here, is by using a delete method. And that can be found here in, I like showing you guys these, all the different methods that come with it. This, once again, is W3 schools. We have the pop one that we use. We use remove. We use pop. And another one is using the delete keyword. And funny enough, I don't use this enough. I've used it maybe once or twice since I've since started coding 2 years ago. But you're able to call the list that you're trying to manipulate, the index itself. But prior to that, you put del for delete. And that does exactly what you think it's gonna do. We have apple, banana, cherry here. It runs the list, and we can print out the list prior to running it and see how that works. So initially it's banana or apple, banana, cherry, and then we delete index 0, which is apple, and we see here that I got updated. So this is another one that you guys can use. There are other ways of doing stuff, so just be aware that you have the clear method. Another one I have not used, and that's one of the reasons why we don't see in the curriculum, because they're not that common. The ones that you'll probably use the most ever is really just pop and sometimes remove as well. But you do have options like clear to clear the entire list or deleting it, and so on and so forth. We have some other methods which I believe we're going to continue covering, but we've seen append, we saw extend, uh, I believe we saw insert, we saw pop, remove, and there's a bunch of other ones here. You can reverse the order of the list, and you can even sort the list. Right, so if you had a list, let's see if it's down here. Oh, it is. We'll get to that in a bit. But yeah, there's a bunch of other methods here that you can look through if you want to. And then some list exercises. I hear questions about, hey, Roger, like where can I practice these things? W3 schools have stuff like this where you can test your Python list skills with exercises. And you come here and try it out. And they ask a question like, what will be the result of the following syntax? And this will probably return to me banana, right? And you can submit your answer and it'll tell you next question. These are very easy, but if you're brand new to coding and need something very simple like this is also an option. So keep that aware. And by the way, this is also fairly new. They changed their UI. This was very different. This is really nice. Before it wasn't as user-friendly. All right, so we talked about how to remove using the remove and pop method, also the delete. We also have two other methods, which is index and count, right? And what this is doing, we see here, we call the list variable, which in our example is the travel bucket list. And they use the dot index method. And notice how they're passing in a specific string Texas, right? And this is going to return the index where X, right? In this case, Texas first appears in the list. Right, and we don't have Texas in here, so it's probably going to return an error. Right, Texas is not in the list. But if we say travel underscore bucket list underscore list dot append, and we add Texas, and then run this, we see here that it does return to us the location of where Texas is at. Let's go ahead and remove it. All right. Oh, they actually want it in here. My bad. So we add Texas in here. Next, we have the count method, right? And that's going to count the number of times that X appears in the list. And you kind of saw this already with the string method, right? Texas should only be in here once. So you, ooh, did we add Texas twice? I'm sorry. Come again. Print travel bucket list. Oh, somehow I accidentally added Texas twice. But you saw that it did return to us too whenever we use count. So it was able to successfully grab how many times Texas appeared in the list. So you are able to do that to count the occurrences of things in a list, whether they're strings, integers, floats, or whatever, right? So you have index and you have count. Count's a very useful one. That might come in handy today when you guys work on your assignments or later when you're working on your own. The next one we have is going to be sort and sorted. These are very powerful tools, especially if you have stuff like numbers. It will sort strings, and you can probably guess how it will sort that. Do it in alphabetical order. Now, Roger, what if I have strings and integers in my list? I believe, if I remember from the top of my head, integers will take priority, so it'll sort them with the integers first, and then once the integers are sorted, it'll sort strings, and we'll see that at work here. So we have sort, notice that they have a flag here, and let's ignore this flag for a moment. Let's see how it looks like without the flag, and we'll talk about what flags are. But if we just say travel list dot sort and then print out travel list, let's print it out before we sort it and after. Print travel sorted list, and then print here. We run the first time, we see Canada, New Zealand, Antarctica in its original form. And now the second time that we run the travel bucket list, it's sorted, right? And you might be wondering, Roger, why is there two of these if they're going to do the same thing? And you'll see that in a minute. When we ran the dot sort method directly onto the list itself, it actually sorted the original order, right? So the original list, right, it actually mutated it. It formatted and it updated what that list was. Sorted is a little bit different. It won't affect the original list. It creates essentially a copy, right? And you'll see how that works. But the dot sort, it sorted our list, and then we were able to print it out, and it actually updated what the original list looked like. Now, you saw this right here where it's sort reverse equals true. And this is known as a flag. And essentially what it is, it's essentially like an optional setting that you can add to your sort method. And one of the settings that it has is reverse. Now you're wondering, like, Roger, like, does every other function have reverse? No, that's just how this function is built. And maybe we can kind of see that within the list method sort. If we come here, oh, I saw it in sort list. Okay, it won't show me here. What if I come here and right click and go to definition? All right, so you're probably wondering what I just did. So whenever you're working on VS Code, and you install different stuff into your code. For example, I have Python installed onto VS Code, onto my computer, and I'm using the Python kernel. It essentially imports all these built-in methods. They're not just coming out of nowhere, guys, right? They're in my code, they're installed. What you can do on VS Code is you can right-click these methods that are built in that we're grabbing from Python, and you can go to the definition, right? This will take you to wherever the source of this method is located at. And it opened up a small window here, and then it shows you where this method or function is coming from. We see here it's coming from VS Code Server under extensions. It's within the Python that we have installed in here. So this is coming from Python. And then you can see where this code was created or brought in, right? Like I told you guys, this is not magic. This is actual code underneath the hood. You just don't see it because there's no need for you to see it. And you see here that they're defining this method, right? They're using the def, so you know they're defining something. It's a function, right? And there's a couple parameters it takes, and this might look a little foreign to you guys right now, and that's okay. We're just gonna check out some of the stuff that's in here, and notice that you'll find here that there is something within this function called reverse, and that is a Boolean, right? It's a Boolean, and by default, it is equal to false. So we give it this optional flag of reverse. By default, it's false, but we're overriding it and setting it to true. And we run this, you'll see that where before it was sorted, right? Antarctica, Canada, Chile, Fiji in alphabetical order, right? Now it's reverse, it's completely backwards, right? So it went, opposite of the alphabet sequence. So it's sorted in reverse order. Do I have any questions on the sort method or the reverse flag? All right, I'm gonna take your silence as compliance. So that was the sort. Now let's look at the sorted. So as you saw here, right, the sort mutated or essentially actually reformatted the original list. It actually changed it, right? And then when we print out the list itself, it was different. It was no longer what it originally was declared. The sorted works a little bit different, right? We can print out the travel bucket list later on in our code. We see here that it's changed, right? It is sorted reverse. This is a new list where before it wasn't like this. It was something random somewhere else. Now let's look at what sorted does. Here we create a new variable. It's called other sorted travel bucket list. And what we are assigning to it is the original travel bucket list inside of this sorted method. And let's comment this out. Actually, let's remove all the extra mumbo jumbo, like the flag. Unlike the sort method where we call the name of the list and call the method right afterwards, the sorted works independently, right? It works independently like a function, right? It works like a function where you call the function name and it takes in a argument, right? That argument is some form of iterable, right? A sequence. This iterable or our sequence is a list of our travel bucket list. It's going to take this list, it's going to sort it for you, and then whatever returns from this is going to be assigned into our other sorted travel bucket list variable. And we print this out, we'll be able to see, we're going to print out both of these, the original list, and we're going to print out the new list that we are creating. And when we run it, you'll see that both of these are different. We use the sorted function and we passed in the list inside of it. And you would think that's probably going to change my list. It did not. It did not change the list. When we print out the original list, it still stayed the same as we had it earlier. And then we printed out that new variable we created. And this one is a copy of the original list, but sorted instead. And what you saw by default before I added this change was that they also were able to give it a reverse flag, right? They were able to give it the reverse flag here. So just like the sort method that takes in a reverse flag, so does sorted. Sorted has the ability to do that. The first item has to be the iterable you're using, and the second item is going to be the flag. And when we run this, it's going to, well, it's already sorted reverse, unfortunately, so you don't actually see it work in real time. But it essentially does that, right? It can use the reverse. Notice that it changed. Do I have any questions on the sorted or sort method and how they work and how they are different? All right. There's an exercise here which you guys can do later on your own. Which essentially you're going to create your own list of places you want to travel. So you'll create something very similar to this travel bucket list. And this will be your own custom list. And then the exercise is to use other list methods to add them to the travel bucket list, right? So everything you learn, you pretty much just go ahead and reapply it to manipulate it within this exercise. But that'll conclude today's lesson on lists. We're gonna go ahead and move forward with the next part of today's lesson, which is gonna be tuples. And this is a much smaller lesson in comparison to the list one. Tuples are ordered collections, right? Similar to lists, but they are immutable, right? Who can remind me what mutable is and what is immutable? Yeah, Stephen, correct, right? Changeable or unchangeable. I guess unchangeable, intangible. I don't know which one's the correct one. English is hard. But mutable means that you are able to mutate it, change it, update it, right? Or immutable is you cannot change the original, right? You can create a copy of it somewhere else or create a different version or reassign it to something else, but the original data type itself does not change. All you're doing is reassigning where what it's pointing to, right? So they're very similar to lists, but they are immutable. So unlike the list where we are able to like change a specific index, we can't do that in tuples. They are pretty much set in stone. You can't go in there and change index one or index two to a whole new value. You have to, it's like you're creating a whole new tuple, right? And unlike lists where you started with square brackets, tuples are denoted or instantiated or I guess declared using parentheses, right? Parentheses instead of square brackets, right? And like all immutable objects, you cannot add, subtract, or edit items in place, right? So if you want to change anything in the tuple, you have to overwrite the entirety of it. Therefore, changing its address or of where it's pointing to, right? The original tuple will no longer cease to exist. It'll be added into collections, and you will now have a brand new tuple reassigned to that variable name, right? Uh, Tuples are really good for data that needs to stay static or that should not change, right? And we see here an example is like days of the week or coordinate pairs, right? That's probably something that shouldn't change. And that's why tuples can be useful. Here we have two ways of creating a tuple. One has multiple and one has one. And I have to specify this because it can be a little confusing if you ever try to create a tuple with only one item in it. To create a tuple, once again, you use parentheses and then you pass in what you want to create in there. To create a tuple with only one element, it looks a little tricky, but essentially you pass in that one element and afterwards you have to pass in a comma. I don't know why it works that way. Who designed it? Just know that that's how it works, right? And then I believe if we run this, it won't print it out, of course. Let's go ahead and print tuple 1 and tuple 2. We see here that we print out tuple 1 and tuple 2 back to back. We were able to create that successfully, but notice that if I take off this comma from tuple 2 that has that one element, it's not a tuple, guys, right? And let's actually see what this is. We'll do type. What is this? Right? It's of class integer. It won't recognize this as a tuple. By default, it set it as an integer. So if you want this to be a tuple with only one element, it needs that comma. And now we see here that it is now a tuple data type. Do I have any questions on how to declare a tuple, whether it's one element or multiple? Right. Tuple operations, right? Tuples are ordered collections like lists, right? So there are some things that you can do that are very similar to lists. One of those is using something like the length method, right? We're able to pass in a tuple. Here, this tuple is called coordinates, and it has the coordinates 3 and 4. And when we run this, the result is going to be 2. So very similar to lists, we're able to find the length of a tuple. And we'll go ahead and print it out in a bit so you can see what that does. And then just like a list, we're also be able to do membership checks, right? We say 5 in coordinates, and we know, because we declared it here, that 5 isn't in coordinates. So this, just like the list, needs to return a Boolean, either false or true. And when we run this, we get the expected result. The length was of length 2, and the check of 5 in coordinates returns false, right? Because 5 does not exist inside of this tuple. So just like this, we're able to use methods like length. We're able to use the membership checks. We're also able to iterate through them, which using like a for loop to iterate through them. So they work just the same. Where they differ is how you update them. Here's another something else that you can use with tuples. You can do the exact same with lists. I don't believe we talked about these during the first lesson, but these are also very common methods that you will probably use a lot within your time as a software developer. And what this method does, the min, max, and sum, is essentially what the name describes. It'll take in an iterable. For example, this one is a tuple type, and it'll return to you the minimum value within this tuple. Same thing with a max, and then with a sum, it'll do something very similar. It'll take all the numbers and add them together and return to you the sum. And if you run this, we see here that the minimum was 1. The max should be 100. Oh, my apologies. There was 678 here. And then they added all the numbers within this tuple together and return to us the sum. Roger, where are you pulling this from? You can pull these from the W3 schools as well. If you go to tuples, go to tuple methods. I guess you won't find it here. Let's go to lists. List methods. We might be able to find min. Okay, we can't find it. Let's see if we do something like Python min. Where is this? Here we go. It, I'm hearing that my audio is off. Is that correct? Stand by. Do I sound better now? I'm sorry. Uh, my spouse got me this headset. It was actually very expensive for it to not, you know, work right. And I have so many issues with it, unfortunately. What a waste of money. But it somehow it works better when I connect the charger. But as I was saying earlier, all right, here's the syntax, right? The grammar, the rules, the spelling of how to create this or use this method. And we have two different options, which is passing in individual numbers here, number 1, number 2, number 3, or just like we used it, we can pass in an iterable, right? And something that's an iterable is something that has a sequence that you can iterate through, like a list or a tuple, right? And we see that both of these work, and you can see here an iterable with one or more items to compare. We see that here with individual items passed in. I don't see if there's an iterable one, but I mean, we're seeing it happen in real time within our code. So that's where the min is. You can also find the max there and the sum if you want to look these up, but that's how they work. We have stuff like sorts, but I do not believe it's going to work on this because we said that they're immutable. So if I run this, I knew it. You see here, tuple object has no attribute sort, so you can't use sort on a tuple. Hence the rule of it being an immutable data type, right? So it will not work tuples. The list method sort, while useful for lists, will not work tuples because they reorder the elements, right? So just like I guess, you can't use sort or sorted, but what you can do is you're able to concatenate tuples using the plus operator, or you can duplicate the tuple using the asterisk. And this is something I added because it wasn't on the lesson plan. So if you don't see it on your curriculum, if you're following with me, just know that you can do this. But here we have tuple 1, which is 1, 2, 3. And then we have tuple 2, which is just the for itself. I have two different variables here. One's going to be tuple 3 and tuple 4, and both of these have two different things happening. On tuple 3, we are adding tuple 1 and tuple 2 together, and we'll see how they can concatenate together. But for tuple 4, the logic on this one is a little bit different. We're taking tuple 1, right, this entire tuple, and we're going to multiply it by the integer at index 0 within tuple 2, which is essentially 4. And you'll see that these have two different reactions. When we do tuple 1 plus tuple 2, it actually concatenates our tuple as expected. This, you would think this might be multiplying it, but it's not. It's actually duplicating the tuple. So in a sense, it is increasing the tuple, but it's using that second number to know how many times to duplicate it. We see here 1, 2, 3 the first time, the second time, the third, and the fourth. So we're able to duplicate the tuple. Also notice that I am creating two different variables to do this, so I don't affect the original. I could do tuple 1 is equal to this, and tuple 2 can equal to that, but that won't actually change my tuple. That'll just reassign it, right? Because we mentioned they are immutable. So I might as well just create two new variables so I don't lose the originals. All right, so we're able to concatenate tuples, and we're able to also duplicate them. It doesn't have to be the item within here. I can just add like 2, and we'll see here that tuple 4 is duplicating tuple 1 twice. And you can do the exact same thing with lists as well. If we did something like list 1 is equal to 1, 2, 3, and list 2 is equal to 4, 5, and 6, we're able to concatenate our list using the plus operator. Let's print this out. All right, so it concatenates a list and adds them together. I don't think the multiplication works the same, but let's see it. Ooh, it does. It works just like the tuple one. I've never tried doing this, so I'm a little surprised myself. But yeah, so I guess we can also duplicate it on the list. So that's some cool functionality that you have access to. Do I have any questions on lists or tuples? What if the list is not a int? Where, Devin? If you're saying like list 2 is not a list and it's a number, this was when we were doing min max. Uh, that is a good question. I don't know if you'll get an error or it might still order it. Let's check it out. Where are you, weirdo? Min max. Did I skip it? Okay, let's say A. Yeah, I knew I figured we'll get an error. Sometimes, because technically, if you guys are familiar with ASCII values, if it was smart enough, it would convert this to an ASCII value and use that to sort it. But I guess not. Or I guess get the minimum or maximum. But no, it looks like we get an error when we try to do that, which I guess makes sense. Hopefully that answered your question, Devin. If I have no other questions, let's go ahead and reach the conclusion. Right. In this lecture, we talked about this and we talked about tuples, the differences between them, how to instantiate them, how to manipulate them, whether it's removing, adding stuff to them, sorting them, and so on and so forth, accessing stuff in there, do I have any questions before we conclude the actual lesson for today? All right. Time is 7:55. We're gonna go ahead and go on our last 10-minute break for today. If you have not done the attendance, please do the attendance. We're gonna come back at 8:05, and when we return, the remainder of class will be working on the assignments that are either here or within the lesson 3 exercises. And we'll take volunteers and demonstrating our code and talking through it. I'll see you guys in 10 minutes. All right, welcome back, guys. We're gonna go ahead and move on with the rest of the day. I was looking through the assignments, and unfortunately, these assignments seem to be a little out of scope. I can't think of a good way for you guys to solve these without using for loops. So what I'm going to recommend, I want you guys to put a tab on this and come back to these later, because I can't think of any way to solve these without having to iterate through the list, and I have not taught you that yet. If you are already familiar with for loops and you want to give it a try, I encourage it for those of you that are already ahead. For those of you that are not, we have lesson 3 exercises. This has been updated on the curriculum today. You guys can find that on the curriculum repo that should be within the bookmarks. And the event you do not have access to, because I know someone mentioned that they can't see it for some odd reason. I'm about to drop it in the chat. So there is the GitHub curriculum for the application. We have, I believe, 9 problems, which should be enough to kind of keep you guys busy today. I see, Nicholas, you were trying very hard to do loops, and I agree. So I'll address that in a little bit, but essentially, these list exercises and tuple exercises should not include anything at all. I created these today. They're fairly simple enough to kind of get you started. You can solve these all without having kind of any iteration, and then go over the principles that we discussed today. So give these a try. At I want to say at 8:20. Yeah, at 8:20 we'll come back and we'll take volunteers to run through these, and then we'll break off again and then tackle the tuples one, and then we'll finish off the night by getting volunteers for that one. But let me go ahead and stop the recording. All right, guys, time is 8:20. Let's go ahead and get a volunteer for the first, let's say, 2 problems. Who wants to go ahead and demonstrate their little solution? Depending how simple they were, we could probably get maybe more than 2. Any volunteers? Kent, do you want to be the first to go? All right, Johnny, go ahead. Share with us, and for the rest of you guys, I highly encourage some precipitate participating in these code demos. It'll do you guys some good trying to talk through your code and show us your work. You only get better but by doing. So take it away, Johnny.
Can you see it?
Yes, I can.
Okay. So what I did was I wrote out a function named empty list, return list equals empty brackets to see if to signify if there's anything empty in the list 1, 2, or 3. Called the function empty list 1. It runs through the program, looks at list 1, sees that there's nothing in, and it prints off true. Again, repeats for list 2 and 3. Goes to the function and sees that list 2 has integers in it, and same thing with list 3. has a empty string.
Yeah, good stuff. I just want to point out maybe not have the space between empty on the second function and the list. I don't see an error here, but not there. My apologies. I should be a little bit more specific. Where you're printing out your functions, the second empty function, um, do you see it? Yeah. Uh, we don't see an error here, but if we want to just stay consistent with our spacing and stuff to have clean code. Good stuff. Let's. You want to walk us through? We can kind of talk through together. Exercise 2. I know you said you didn't finish it, but let's
I
just
even
talk.
started. I just finished
Okay,
one.
yeah. This one, the first couple ones are fairly simple, but yeah, it's telling us to write a function that checks if a specific value exists in a given list. And this is something definitely we covered. So why not go ahead and let's go ahead and declare that function.
Write a function that checks if it's. So write a function that checks if a specific value exists in a given list. So define function. This value in a given list. Let me see the other one. I'm probably gonna have to write it out on a notepad because that's what I did with the other one. That's why it took me
Yeah,
so long.
yeah, that's I mean that's okay. And this is part of learning. So yeah, we want to create a function, and remembering back our naming conventions, we want to ensure we use letters. It has to either start with a letter or an underscore for our naming conventions. We want to ensure, if we have multiple words in our name, we probably have underscores to stick to the snake case convention for Python. And then we probably want to make sure it's something that's relatable to what we're trying to do. So here we're trying to see if something exists within given list. So maybe call it like define value in list or whatever. Something very similar to that value underscore and in underscore list. Right. Whatever makes sense to you or you think will make sense to other developers. And then we
Okay.
open and close our parentheses. So now we can start defining our function. And what should this list probably take in? Or what should this function take in?
A parameter of some sort.
Yeah, the parameter, which should probably be whatever we're trying to check, right? So the parameter, what do you think that parameter should be? And it's going to be fairly simple to the exercise 1.
That would just be like it's kind of like what I did with that first one.
Yeah, very simple, right? We're defining one parameter, and the naming convention of this parameter is LST, and it's kind of letting us know, hey, this should probably be a list. Now that we have the ingredients for this recipe, we want to add some kind of actual concept in here. How do we want to check if something is within the list? Essentially, this is a membership check. Is that right?
Say again? I cut off there for a sec.
Yeah, so essentially by checking if something exists in a given list, that's what we call, if you remember from our lesson 2, a membership check, right? So how do we check if something exists in something?
I don't remember that method.
Yeah, we're using the in operator. Do you recall that?
Okay. So yeah, I feel like if A is in list 1, then it'll populate.
Yeah.
Okay. So be return in, I think it's, so we return A in list 1, correct?
Close. So now we are seeing that we're probably going to want to have some kind of other parameter that we want to check against our list, right? Uh, because we want this to make it dynamic. We want to make it so whenever we run this function, we can pass in 2 different values. One is the value that we're trying to see if it exists, and the second value will be what we're trying to check it in, right? Does that make sense?
Yeah, kind of, sort of.
Yeah. So, for example, let's look at list one. Let's say I want to see if the letter B is inside of list one.
Hmm.
So my function should probably take two arguments. One argument will be the item or the data, the value that I'm trying to check for, which will be B, right? The
Hmm.
string B. And the second argument or parameter should be the item or data structure that I'm trying to check inside of, which will be the list. So those are two parameters that we should probably tell our function that it should be expecting, right?
Okay.
So within the line of define value list, uh, no, the lineup where you're defining your function above, right? So right above that, uh, and your parameters inside your parentheses, there is where we want to let it know what arguments we should be taking. We already have one, which is a list, but we also need a second one, which is going to be what?
I guess it's string in this case if it's list one.
Yeah, it could be a string, but notice that we also have other lists. One list has integers, right? So it's
Hmm.
not always going to be a string. We can keep it simple and call it just like X or Y,
Hmm.
or we can just call it value one, whatever you want to call it to let you know what it is. But essentially, one of these parameters is the item that we are looking for, right? So now when we call this function, it's going to take two things: the item we're looking for and we're checking if it's at, right? Because our function needs to have access to these two items. So now we have X and we have list. How do we do that?
Like
There
that.
we go. Awesome. Now we're working. Yeah, so return X and list. Because this is a membership check, what should this return?
Say again? You cut off.
Because this is a membership check, what will
Hmm.
this return?
So it will check if X is in the list. So like for example, like if we put in A, it'll check if his A is in the list. If we check if 2.3 is in there, it'll check if 2.3 is in the list. Does that make sense?
Correct. Yeah, so it'll check, but what kind of value will we get back? Is it going to tell us a
Oh,
number? Is it
it'll
going to
say
tell us
true
a
or false.
awesome? Yeah, that's what I was looking for. It's going to return a Boolean, right? True or
Mm.
false. And that's kind of what we're looking for here. But I just want to make sure we're understanding what this is returning, right? So let's go ahead
Mm.
and we'll print out. We want to call the function just like you did, and then give it the different arguments. And you're probably gonna have to write this line 3 times for all three lists. For the first list, let's look for letter B. There you go. You're on the right track. Awesome. And now let's do that for list two and list three. For list two, let's look for the item at index 0.
Index zero. Okay.
For list three, let's look for the index for the item in list three of index 2. So in short, what this should return to us for all three of these, the first one should return to us true because B is
Mhm.
in there. Honestly, all of these should return true because they're technically in there. So run this. And what are you getting here? You're getting true
So
for the
true
first
for
one,
the
right?
first one.
Why do you think we're receiving false for the second and third one?
Mm, maybe because I'm using the brackets for zero instead of actually writing it out. Yeah.
No, not necessarily. It's not that you're wrong that you're using brackets, but it's not the correct syntax. Who wants to help out
Hmm.
Johnny on this of how to access the items at index 0 or 2? You're on the right track, but you're forgetting something here. There we go. We got a response from Nicholas. You want to call the list that you're trying to access, and then you tell it what index you're trying to access, right? Here, the second argument you're passing in, all it's saying is bracket 0, but it doesn't know from where. What list do you want
It
to
would be
check
like that.
index 0? Uh, Kinda, but they both have to be separated, right? Because the function we have it set up so it takes two different arguments. So the first argument is the list that's checking, and the
Mhm.
second argument is the item that's checking for. So you're on the right track, but you have to separate them. There we go. List underscore 2. You have to specify on both of these.
Okay, that makes sense.
Yeah, awesome. And then if we run this, now we get true. Great work.
All
Did
right,
that
that
help
makes sense.
out, Johnny?
Yeah, I helped out.
Right on. All right. Thank you,
Sweet.
Johnny, for sharing. Let's go ahead and get another volunteer, somebody else that can walk us through the next two one. Come on, guys. We got 19 people in here. I know we got people to share some code or at least attempt. And that's honestly all I'm looking for. Even if you don't have it complete, we can talk through it just like we did with Johnny. Let's see it, Devin. Devin Jackson or Jack. Also, Devin, I believe, yeah, you said your mic was not working. Okay. All right. Let's do one then at least. It would really help if we had a mic so we can communicate. If you have one already complete, you can go ahead and kind of show it to us. And then I can talk through it for you. Okay. All right. Yeah, we'll try mm, let's save you for later, Devin. Go into your Zoom settings and see if you can fix your audio. It'll make it a lot better if we can communicate to actually make this a little bit more interactive. All right, let's get a volunteer. Can I get Esperanza Cirillo? I know that you were active in the chat earlier, so I'm sure you should be there.
Did that do it? I think that worked. There we
Devin,
go.
perfect. Let's get it, Devin.
For sure. All right. How do I share my screen in here?
At the very bottom, you see a blue square that has an arrow. It should say share. Click that, and it's gonna tell you what screen or application you want to share.
Okay. Share.
Love your dog, by the way. Awesome picture.
Thank you. All right. Let's see where we are at
Do me
here.
do us a favor. Go ahead. I want you to close down that this right here. Close that up
Um,
to give it some space. On the left side, you should be able to click the toolbar of the there we go. And then I want you to close this off too, since we don't need it. There we go. Now we can see a little bit more. All right. So talk us through, what do you think? What's your thought process behind this?
all right. Write a function that checks if all elements in the list are identical. Return true if they are, otherwise return false. So define the function of identical with two parameters. I don't know. My thought is two parameters to compare the first item to the second item.
Yeah,
But
that's absolutely correct. I mean, we want to be able to grab both lists, right? So you're on the right ball track here. Yeah, we want to have two parameters.
okay. So then we want to check, do not use loops, so I can't use if.
That's not a loops. I just meant for those of you guys who are familiar with loops. Yeah, we don't want to use
Okay.
a for loop because I know some people are a little bit more advanced. But we don't want to use loops.
I guess I don't know how to do this as a like a boolean. I could do it as like a output, I guess. The way I would do it would be if x is equal to y, then I would print true. This is wrong somehow here, maybe not. Else print false. And then I need to return I need to return something. I'm not sure what though.
Yeah. Well, let's try this out for now. You can just keep it like this to see how this is working. Oh, look at this. At the very bottom, we have expected output, return true or false. So we're printing it here, but maybe we can change this to return true or false instead. It's not that what you're doing is wrong. This could work just as fine too. But you know, the expected output is to print something out. This is fine for now. We can just keep it as return. You're getting a squiggly line right here because of the indentation.
Indentation.
Correct.
This needs to be inside, right?
Yeah, there we go. Perfect.
Okay, so then we want to print the identical. Then we're gonna go list one. So we want the index of the index of 0 compared to list one index of 1.
Why are we checking, or what is your thought process when checking the specific index of 0 and 1?
Because it says write a function that checks all the elements in a list. So yeah, I guess the way I was doing it, I would have had to add like another parameter to check each I forget the word, each part of
Each
the list.
each integer. Yeah.
Yes.
Well, uh-huh.
But I guess there's a better way.
Well, let's fix this function a little bit. Let's go ahead and add the colons right here. Right. So to let it know that we're starting a function. There we go. That's why you're getting that squiggly line. The x and y, right, is the arguments that we're supposed to be passing into this function. And the way that it should work is we want to pass in two lists, right? And then within this function in here, we want to do the logic of checking if those lists have everything, right? Because the question is, check if all elements, right? All elements in a list are identical.
Okay.
Right? So what does that mean? Well, and you see if 1 and 1 and 1 are all the same. Is everything within this list the same? So we do not need to pass in two arguments. We're only going to check if a list, not two lists, but checking if everything within that one list is identical. Does that make sense?
Yes.
Yeah, so we probably do not need two arguments because it's only going to take in one list, and then we have to check if everything within that list is the same, right? Notice that list one is, they're all ones. So technically, this is supposed to return true to us. When we run this function a second time with list two, it's going to return false, or that's the expected output because this is there's a two in here where everything else is one. Right. So here I have the explanation for you guys, or the example of what it should be. The first one will return true, and the second one will return false. Now,
Okay.
knowing this information, we have to kind of fix our code to handle that. Since we are now only using one list, we're not checking between X and Y. Does that make sense?
Yes.
Now, how can we check if something is equal to itself on a list?
That's the part that I don't know.
Okay, well, let's break it down. Let's take it one step at a time. Let's see how can we check if index 0 is the same as index 1. Let's try that one first.
So would it just be if X index 0 is equal to X index 1?
Yeah, you're on the right ball track. Exactly. That's exactly what it is. Right. We're checking if X, which is supposed to be list 1, if index 0 is the same as index 1. So that's how we check if two specific indexes are the same. That's a good start. Now, how can we check if everything is equal to another? How can I explain this? How can we grab everything in here to see and compare it against another version of this to see if they're the same?
Not really sure, to be honest.
All right, we're gonna try this. Let's use slicing. Let's check if everything after index 1 is, oh, let me see if I can type. I think I can type. Oh, that's another good way, Johnny. We could try that. Maybe take Johnny's advice on this one. He said, can we use count? Well, Johnny, do you mind explaining to us how count works? What is it doing?
If I remember it right, it did say, for example, I think it takes like index 0, which would be 1, and I think it goes to the list to see if that 1 is in index 1 and index 2. If that makes sense, if I explain that right.
Close. Count is going to check how many times something appears in a list. So that's actually a great way. What if we grab the item at index 0 and then ran the count method on it, right? And then how do we ensure that that count matches the whole list? How can we do that? You're on the right track here, Johnny. That's great stuff. Length. There we go. We got Nicholas now joining in. Yeah, we can use a length. So if we check the count for 1, if it's all the same, technically the count should be matching the length of the overall list. Does that make sense? Yeah. So let's try that out. Devin.
I'm not gonna lie, that didn't make too much sense for me. Because my thought would be like the count wouldn't that'd be like a iteration. I don't know. I don't know.
I mean, it would be iteration, but we're not using a very specific. We're not deliberately using a for loop. I think is the trick here, right? We don't want to use for I and range or whatever, or do a for loop because we haven't been taught that. But I did teach you guys the count method. So, how does the count method work? Do you recall? You can check the curriculum. You're more than welcome here. Let's go ahead and open up that curriculum.
Where is
Right.
that at in here?
Yeah, click there.
And then here.
It should be in lessons, ordered.
Additional.
It should be lesson 3. And then you can do list methods right here. Click that. And then we see here the list.count. returns the number of times a specific value appears in the list. So if, logically speaking, if everything in the list needs to be the same to return true, that means the first item, the amount of times that appears in the list should match the length of the list. Does that make sense?
Yes, but then when we have to find like the length of the list also.
Yeah, and we did talk a little bit about how to grab length. How can we grab the length? Do you remember?
Yeah, is it like len dot and or length parentheses of the list or the whatever you're trying to call?
Right on. We're on the right ballpark here. Correct. Right. We used the len built-in function. So we want to be able to grab the count of the first index, right? And then grab the length of the overall list. And then we should probably compare them to ensure they match. If they don't match, that's telling you as a developer that there's probably an additional item within this list that should not be there that matches the rest. Does that make sense?
Yes. Okay, so I'm just gonna start over.
And that's okay. A lot of times you'll find yourself doing that as a developer.
Okay, so we're gonna do list one dot count. Um, and then we do list one index one.
Yes. Remove this space here.
Okay, so we also need to find the length of list one. Okay. And then we need to compare the count to the length.
We're moving. Yeah, we do.
So to do the count, how do I return the count?
Well, how can we save that count somewhere?
Oh, okay. Variable.
There we go. Yeah, we can create a variable here.
So we'll just do, can I use count as a variable?
It's a built-in method, but I
Okay.
think it should work. We can say x count, x underscore count, or something like that. Whatever you want to call this, right? X count. That has some kind of meaning, right? So this is going to count how many times the item in index 0 of list 1 appears, and it's going to save it into this variable. So now that we have the count for that, what do we also do for the length now? Okay, yeah, we're in the right ballpark. Let's go ahead and remove this parentheses and this parentheses. So we have the count on one, and we have the length on another. What's next step?
Would be comparing them.
Yeah,
So the X count, oh, if X count is not linked list, then we want to print.
let's not print. Let's return. Let's get used to returning stuff.
Can you
Uh,
get two returns?
if you recall the exercise from the last class, we were able to do multiple returns in different blocks, right? What does if and else statements do for us? It gives us the option to check different conditions. and only one will return depending if it passes, right? And that's kind of what we want to leverage here, right?
Okay. Return. So if this is not this, then we're gonna return false. Else we're going to. I need this here. I think it's there. And we're going to turn true.
Yes. You might want to fix the true. Okay. Now we're almost there. We are 99% of the way done, but there's an issue here with your code. What's going on with the way that we are declaring the function there? And the parameter, and then the way that we are using that parameter. Where is that parameter being used?
I guess it's not. So I would have to do this right here. Change that to X.
Correct.
Change that to X. Change this to X.
There we go. I think we're cooking now. Let's go ahead and try that. Run that bad boy and see what it gives you. You got to scroll down, and we got true. Okay. All right. That's working out so far. Let's go ahead, copy and paste this right below it, but change list 1 to list 2. And there we go. We get the expected output of true and false. Good stuff. Good stuff,
But
Devin.
what is these down here?
Where am we getting that? Don't worry about it. It's probably this.
Okay.
Yeah, don't fret. It's just the syntax for Jupyter Notebook. But yeah. Do you have any questions?
No, I guess just, taking the time to just mess up and re-go through it to learn it, I guess.
Yeah, absolutely.
Figuring it out as you go.
What would the splice look like? The splice one, I believe that's Joshua. It would look a little bit more complex. It would look something like, let me show you. I'm gonna type it in on the screen. Return. Oh, okay. I'll type in the chat. It will look something like this. It's in the chat where list 1 and to the right is equal to list 1 to the left. But yeah, that was a really good one. The one that you brought up, John. That's a very simple way of doing it. And good job, Devin. Very receptive to the information. But we're gonna go ahead and stop the recording now.